Hello, hello. This is day 4 of Leetcode. I was supposed to Leetcode yesterday, but I ended up chatting with my sweet mate for quite a long time at night. So I guess I'll make up for it today. As you can see by my streak, I only did it a Friday, Saturday, and then Monday, and then I skipped the last 2 days. Okay, but trying to just make time for everything I can at this point. So today, I looked at this problem I think yesterday, and I don't know what to do with it. So I'm gonna say that for later, until I understand like what exactly like encoding decoding means. For now though, I'll just I want to start with linked lists actually. I just learned about it in my class today, but or not class, but we had this like online assignment. So I'm gonna try to learn or do my first linked list Leetcode problem or neat code. Let's do the first one. Reverse linked list as usual. I'll set up a stopwatch. Around 5 minutes to just read the problem and see what is happening. Okay, start. Given the beginning of a singly linked list head, reverse the list and return the new beginning of the list. Example 1. Your head is 0, 1, 2, 3, and the output is 3, 2, 1, 0. Head, if you have an empty list, then you should get back a empty list back out. Constraints. The length of the list should be between 0 and 1000, and node value should be between -1000 and 1000. Okay. So what I learned was, this is how you implement a node of a linked list. Each node is, or in this case, the list node is the object. It will have instance variables, some sort of data associated with it, as well as a pointer to the next node. And it will have, of course, a constructor, then a no arg constructor, then an actual constructor which initiates the value, and another constructor that initializes the value and the next node. Before I would see the time complexity, recommended time and space, I think I'm going to take a guess at it first. From what I know right now, if I want to reverse the linked list, I would have to go through each element and change its head, or I would have to change its next node, and of course I would have to change the head and tail. I don't know if this utilizes tail, but in this case I'm pretty sure it just utilizes head, where actually maybe it does utilize tail. But from my understanding, 3 becomes the new head and 0 becomes the new tail. From now on, 3 has to point to 2, and then 2 points to 1, 1 points to 0, and 0 points to like null. That's essentially what I gotta do. And if the given list is empty, then I gotta return nothing, or an empty list. So I'm assuming this would take a O(n) time, since we're gonna go through each element in the list. And space complexity also would take, I think, O(n), or O(1) space actually. Because we're always gonna be given. Okay, that makes sense. Okay, let's start planning it now. Take around 20 minutes to plan. Okay, starting now. Alright, first I want to write out or visualize an example of this thing. Alright, so first we have 0, let's say 0, and then it points to the next one, which is 1, and then it points to the next one, which is 2, points to the next one, which is 3, and the point's just null, I'm pretty sure, and we're only given the list head. So once we're given the list head, we should be able to once we give him the list head, we know that this has to become our last element in the array or in the linked list. So now it would go like this: 0. Maybe I would have to actually start at the end of the list. If I start at the end, then 3, and then points to 2, and then points to 1, and then points to 0. Problem is that we're given the list head. And if I want to find the end of the list or the list tail, then I'm gonna need to go through the entire linked list, and then once I get there, I'm gonna be like, okay, this is my starting position, and this is my new head, and I would have to traverse back. Okay, so if I traverse the array twice, okay, that's still O of n though, but maybe there's another solution to it. If I'm gonna do the, I need to. Initially that happens here, but if I have, okay, I think I'm gonna need to go through the list. Yeah, if I want to go through the list, I gotta get the head, and then after that, I'll make my way backward. Because as I go through, let's say like I want to change the pointers as we go through, as we iterate through the linked list. If I want to do 0 and then 1 at first, right? I want to change the order. I want to go 1 0. I'll end up pointing. 1 will end up pointing to 0, but then there's no pointer to 2, and so I just lost that pointer. So yeah, I guess I'll have to traverse the array once and then another time. Okay, so I'm just gonna be like 4. I'll make a for loop. We're just gonna loop until like loop until or no, I can use while loop actually. While next is not equal to like null, and then once it is null, I'll realize that I got my head. So like, so I'm gonna have like a variable like keep track of like the new head. So like I'm just gonna call it new head, and I'm gonna keep updating new head. I'm gonna be like, well, new head is like gonna be equal to currents. And then when we get to a I think our new head is equal to next. I think I'll just do equal to next. Because when we check the next, we're gonna be like, let's say we're right here, right? Or we're gonna be checking next. So like, oh, next is 3, so that means that the new head must be equal to next. But then once we get a 3, we're like, okay, next is equal to null. So this loop won't like iterate at all, or it won't go through this loop at all. And so once I find the new head, I'll be okay, but now, once I have a new head, I need to point it to the next 2. I think I'm gonna need like another while. Or old head. Maybe I'll have like an old head. Sounds kind of weird. Old head. Alright, I'll have the old head, which is like equal to like 0 in this case, and is equal to 3. Or this won't be initialized at all. It'll actually just wait till we get through that. So yeah, once I have like while, I need another while loop to like iterate or to make sure that I have to iterate through it again. 3 to 2, then 2 to 1, and 0 points to null. Head is equal to next. So I'm gonna be like, while the current head is or I'm gonna do like another while. Problem is that 3 initially points to null, and I wanted to point to 2. Okay, maybe I'll have like just a hard coded line here. So like if null, I'm just gonna have like how would I reverse it? How would I? What would I do? Once I find a new head, I need to point to 2, but in order to point it to 2, how would I get 2 in the first place? I can't backtrack either, or I can't, because 2 only points to 3, 3 doesn't point to 2. Maybe instead of doing that, it would just be like, oh yeah, once I find, once I get 3, I'm gonna have a part where I point it to 2, but also 2 will have an instance where it will point to 3 still. But 2's gotta point to 1, and 1 points to 2. If 3 goes to 2. Problem with linked lists is, in order to access a value, I gotta iterate through the entire linked list to find that value first, because everything is just a pointer. There's no actual, like, it's not like an array where there's indices that are associated with each one. Alright, it's 10 minutes, so I'm gonna use it one hit because I'm getting lost. I don't know any direction to go. Brute force solution would be store the node values of the linked list into an array, then reverse the array. Return the new linked list head. Okay, I did think of that brute force solution at first, like turning into an array. But that's kind of like, I think there's a way to approach a reverse. Oh, to reverse a linked list in place. Okay. So of course we don't know how to create anything new. We just gotta. This would be an element solution. We use it. Okay, brute force won't like help. I'm not gonna implement that because, or maybe I could. No, I want to implement the optimal solution. I'll go for him too. Okay, that was what I was trying to do right here. What if I'm trying to reverse? Okay, it's from 2 to 3 here. 2 to 3. If I want to reverse it, how do I reverse it to 3 to 2? Because 2 has the value, like, the next is equal to 3. And then points to null. And also it becomes the new tail, or it becomes the tail becomes a head, and the new head becomes a tail. Oh. How would I do that though? Huh? If I want to reverse just the two sized linked list, 2 node linked list, how would I go about it? Reverse just the two sized linked list, 2 node linked. 2, 3. So, like, let's look at just 2 for a second. The next is equal to L6K node 3. And this one, the next is going to be equal to null. How would I reverse it? I'll just be like, next is equal to, how would I access the previous? I can't do that. Next equal to how would this work? What? I need to set the next is equal to 2 and then 2 points and nothing. It's gonna point to 2, but how would I even implement next is not equal to? I can't just say no 2. How would I know it's no 2? Previous? Is there anything that shows the previous? It only shows the next. Huh. Okay, this has a point to. The next pointer has to point to null. But I want to create like another type of. Do I have to create like another temp node maybe? I'll have like a temp node that says. Go ahead. Second node equal. Second node. To node. Let's say just I have like a. I'm not sure how to do this. Next element or 10 pointer to track or temp. Change the first pointer. I want to change the points pointer. Maybe I should store an element. Wait, I should have each node store an extra node. Oh, but that's basically a doubly linked list though. Okay, I might need another hint. Wait, no, consider list 2, 3, where 2 is the head of list and 3 is the tail. Where 3 comes the next pointer will point to 2. Then 2 is the next pointer will point to 1. Okay, that's kind of what I already been trying. What I've been trying to do. Oh, it's for the same example. I put 2, 3. What the heck? It's 2, 3. 2 is the head of list and 3 is the one we reverse it. 3 becomes the new head. So I like keep updating like a head pointer rather than a next pointer. I'm saying. So maybe I'll say like, maybe I'll update head. Like head is equal to next, and this one right here. Because after the result, you needed 3 3 points to 2 points to null. So head will equal next. And then I'll have 2 points to null. So like. I know, just like next equal null. And then for 3, in this case, I'll have maybe. I'll have like current equal head. And then maybe head is equal to. Wait, no. Okay. think I need before changing. Okay, so my first approach of changing the 2 pointers in place right here, and then getting rid of that, and then getting rid of that. My problem was I got rid of that. I can't get rid of the next pointer. I have to keep that pointer intact. Let me try that again. Okay. I did have an idea of it in the first place, but I ruled it out immediately, which is not a good idea. So right now I say like head is equal to next in this code. The head's gonna be equal to next, and then we're gonna have it point to null, so like cur equal null. And then that's for that one, and then for this one, once we have it pointing to null, and head is equal to next, so that's the pointer. Or sorry, that's not the current, it's next. Have the next point to null, next that way, and its head is that way. And now we're gonna repeat the process. We're gonna do now we're there. We're like head is equal to the next one again, and this time we would do next is equal to it's gonna be that node, but how will we get that node there? How will we oh no. Oh, I would first not do that. I would do our next is equal to head is equal to next. Next is equal to head. Wait, that one makes sense. Okay, I'm just confused now. I think we need to. I think it'd be better if we had a third pointer. If we had a third pointer, that makes things much easier. Like. Okay, let's say our we're gonna keep track of the next one. So like next is equal to just next. Or sorry, I'll just say c.next. Just keep track of that because that looks confusing. Current or the next. So next is equal to the current next, and the new pointer that we were originally at has to be reversed. So it'd just be c.next, is equal to, let's say, some previous pointer. I'll just call it prev. So next equal prev. So keep track of the previous, and finally I need to keep track of the oh wait, do I need to keep track of it? All I gotta do is move around this stuff. Next, preview. And let's say the previous pointer, in this case is that preview. Previous, I could just do like previous, like, is equal to the current, because let's say we're like right here. Like right here, our previous is equal to current. Oh yeah, because this is our, okay. And then current, oh we gotta update our current too. Current will be equal to like, equal to the next. I think this works. Okay, I think I understand it. Oh, it's already been 30. Okay, let me start the code already. Let's start coding. Okay, originally I wanted of course we're given the list node head, so list node current is equal to head. We're going to do that first, and then we need another list node previous, and that's going to be equal to it's going to be equal to null at first, because we're going to be pointing it to, like, if we reverse it, right, the first thing that's going to, the previous before, or that should exist, is just like null. And list node, I need the next also. Next, I don't think I got initialize it, because we haven't done anything with it yet, so I don't think I need to do anything with that. I can use the while loop, yeah. The while loop is for while the next is not equal to null. So, or no, next, sorry, while next is not equal to null. I can just use next too, actually. I'll just do next. Well, next is not equal to null. What was my first order? Okay, I was gonna store the next node. So next. Okay, this one I initialize next. Next is equal to current.next in this case. Because if we're at the current node, then we need to get the next node, which is just this node, and then I'm gonna initialize it already. After that, what I need to do? Current equal preview. Oh yeah, we gotta. Equal preview. We're saying like the current's next object should be the previous one. Doesn't. let's say we're here, right? Or oh no, we're at the line after. I forgot. We're gonna set back the previous to there. So like, let's say previous is that, right? We're saying at this line, our current dot next equal previous. So instead of pointing back to the right, it will get rid of that pointer and then point to the left. Okay, that makes sense. Current dot next is equal to prev, and then of course I gotta reverse it. So previous is equal to previous is equal to current, and of course current is equal to next. Return the new beginning of the list. At the end, it should just be return cur, isn't it? Or just return cur, because at the end, the loop will end up realizing that current equal next will just be null. Yeah. Okay, is that it? I think that might be it. Let me run that, see if it works. Oh, I misspelled that. Next variable's not initialized. Huh. Oh, I could use cur too, can I? Because current is already initialized, and then current, like, while current is not equal to null. Yeah, because it's going to like a next. Yeah, okay. Uh-oh, wrong answer. What did I do wrong? Let me trace out my code. So say 0, and then 1, and then 2, and then 3. So let's say we have in the beginning, our head is the current, and then our previous is like null. So prev null. And less. Okay, so while current is not equal to null, next is equal to current dot next. So next, this time after you execute that, we have next is equal to like 1, or like that one. Then we have current dot next is equal to previous. So we say that we've modified this one. So this one's current dot next is equal to previous. So we're modifying this next. So we have like next is equal to, in this case our preview was null, so when previous is equal to cur. So cur in this case is that one. So we have previous is equal to like the 0 node. And of course we have our current is equal to next, so then that goes to the next node. And now we have current. Current is not equal to null, so that's good. And then we have next. Okay, we modify next again. Next is equal to next dot current. So this time this will not be a null. It will be equal to 2. and then we have our previous, and then we initialize this next is equal to the current on prev, and we already two-step. Previous was up to 0 here, and now previous is, sorry, that's not it. Alright, is it 0? And now we say previous is equal to current, so previous is equal to 1. There you go. And then we have current on next. So after we say preview is equal to 0, it now points there. And then preview is equal to 1. And now we're not there yet, I think. Yeah. So right now we're saying preview is equal to 1. And now we go back and we say current is not equal to null again. Next equal current on next. So this time next is equal to current on next, and it's now equal to 3. And then we have our next is equal to the previous. So the previous is just 1. And now we modify the previous here. Previous is once again equal to the current. So that's just two, and then current next again, and now we have initialized this pointer to point from 2 to 1. Oh yeah, previous was null, so like it'll point to null here from this code at the start. And once we get here, we're like, oh, next, all current is not equal to null. It's not equal to null, yeah. Next is equal to current on next. Well, it doesn't point to anything, so it's just equal to null. And then we have current on next equal prev. There is no current on next, so it's null too. Previous is equal to current, so now previous is equal to current, which is 3, and now we officially have pointed back to 2. And then cur equal next. Well, there is no next, so cur is equal to null. Oh, wait a minute. Okay, I found the bug. I'm returning cur, but at the end cur is actually null instead of anything else. So that's why there's like nothing being produced in the output. So instead, I would need to produce the previous. I need to return the previous in order for it to work. Oh wow. Hey, there we got it. Oh, it took 40 minutes only. Okay. I think I got it with this one. Oh, that's nice. Current equal null. Yeah, because right here, previously initialized at 3, and then 3 is our head now. And we got rid of all these pointers. The points and now it points back. And then, of course, 0 points to null. Okay. I think that sums it up for today's stream. That was a pretty nice and fast Leetcode. Faster than I expected. Let me submit this really quick. Let's make sure I did everything correctly. Okay, we passed all the test cases. For such a little amount of code, it got me stressing again. I didn't know what to do. But now I know. That was pretty impressive. I managed to get that done. Okay. I'll see you guys for stream tomorrow, probably. And yeah, I'll end it now.